Hello, guys. Welcome back to another episode of the Cloud Chat. It's been a while, but we are back again. And this time we're here to talk about how to the different ways in which we can actually monetize your application. And
Yeah, I think
someone is
Damien.
also here. Yeah.
Yeah, hello guys. So I think Damien, what I was going to say is, like today's topic will be very interesting for someone who's having a current product which has a single customer maybe. So I think the plan is to talk how to get this product beyond. So like scaling up basically. So I think this might be a very interesting topic for. I mean, it's personally very interesting for me. I think for you as well, how to scale up a single product. So
Exactly. It's
before,
it's
yeah.
the natural order of all the
Yeah.
things, right?
Yeah. So you're at a level where you can, focus and take this forward. So what are the steps in this cloud domain? So we'll be mainly focusing on the cloud side, not not the billing and the motivational and business side of things, just cloud side of things, which is our area, which we are going to talk about.
True, and
Um,
we'll also be talking a little bit about the developer friendliness of it, how easy it is
yeah,
for developers. Yeah.
yeah, exactly. So David, do you want to like give a quick intro maybe beforehand? How the product life cycle comes to this stage. So we basically start with a small idea. Let's say we are building a invoicing software, for example. We'll just get a small example. So we build a company invoicing software, and then we come to a point where we think, okay, this is very good, very stable. The entire company uses it. Can we actually sell this invoicing software to I don't know, another customer or 10 customers? So I think that's the sort of story.
Yes, I mean, that's sort of what happens when you sort of capitalize on the product, right? So you have a
Yeah,
team of really good software engineers, or you yourself are a really good software engineer. You build a really good product, a company wants it, they're willing to pay a fee for you, to you, so that you can continue working on it, and also so that they can also use it. And then the normal way it happens in the industry is that either you get motivated, okay, I can sell this to someone else, or it
yeah,
spreads through the word of mouth. So someone else might come and say, okay, look, I want to use the software now as well. Um,
yeah,
Normally, when you go into designing the initial software, you really won't think about giving this out to multiple maybe entities, or we can call them tenants.
yeah, yeah.
And then you need to do a little bit of changes in order to support all of them. I mean, there's lots of ways in which you can go.
Exactly. Yeah, I think that's the idea of when we like have cloud infrastructure. It can be like built in 10 different ways, the same concept, same product. So again, when scaling up, it's the same scenario, I guess. Yeah, I think we can get on track. So what do we have
Yes.
first?
So first we have this little article by Digital Garden, I believe, um, which is SaaS single tenant versus multi-tenant. So basically, what's the difference? So before we get into multi-tenancy, let's just sort of clarify the word here by the meaning of tenant. So a tenant is basically a group of users within your product. So, for example, maybe you have multiple. Again, as an invoicing software, you might have multiple warehouses. You might have multiple restaurants. You might have multiple clients using them, and each of those clients have multiple users within the system. So this is sort of like a macro level sort of terminology where we define the major sort of clients within a system. So a single tenant would basically be, okay, you're selling your invoice software to one person, one company, and that company is only using it. Whereas a multi-tenant would be like 2, 3 companies actually using your software here.
Yes.
And yeah, so again, multi-tenancy is all about sort of a SaaS sort of product.
Yeah.
But again, there are sort of different types of single tenants as well. So, for example, if you sort of take your product and say another company comes and says, "Okay, I want to use your product as well," and you go and you install the product on a local sort of server in their sort of company within their ecosystem, that will still be considered as single tenant
Six.
because
Yeah.
the software is only designed to to serve one company. So you would have multiple clients, yes, but you would still have only very single sort of tenants. And a very good example of this, I think, is ATMs. So ATMs are basically single tenant systems, the ATM client itself, because those have their own operating systems, they have their own softwares in them, and whenever you want to do an ATM update, now there might be ways in which you can do it remotely, but I remember some time back you would have to go into each and every ATM location and you need to manually update the software within it. Also, another example for single tenancy would be you have these sort of old organizations that don't want their data on the cloud, and because of that, you would actually go and install your software on their servers or on a laptop or on a computer running within their shop or within their enterprise, and that would still be single tenant because it's still serving only one tenant. The thing with multi-tenancy is that this is sort of the way this sort of evolved is not really for it's not really a huge benefit for sort of marketing, but this is more or less a huge benefit for maintenance, for development, as well as for getting a good profit on what you're actually selling.
Yeah.
So the thing with multi-tenancy is that you have just one software, or maybe you have when I say one software, I mean one huge architecture. So it can be just one desktop application, or it can be multiple microservices, serverless apps, an entire ecosystem behind it. But for now, let's call that just one software. And that software would basically serve multiple clients. So a good example of a multi-tenant system is maybe Facebook. So Facebook, it's just one place where you log in. You have your own profile. Everybody else has their own profiles as well. And yet all your data is still stored within Facebook. You don't have a separate instance of Facebook running on your own computer. Another good example might be, of course, stuff like HR softwares.
Yeah.
Or we have these stuff like, FreshBooks and stuff, accounting softwares that run online now. They also have local versions which you can actually deploy on your premises, but for the most part, everything has sort of moved to the cloud. A very sort of new multi-tenancy system or entry to the multi-tenancy world or SaaS world is also Office 365. So earlier you used to have Office on your desktop, but now with Office 365 you have it on the web, and you just log in and you use the same features, the same product, but now you just use it on the web and it's hosted in a centralized location. So
Yeah.
that's
I think they
basically
mean
multi-tenancy.
like huge products like Salesforce would be, I think, good
Correct.
examples for multi. Yeah, they are like,
Correct.
I don't know, enterprise grade stuff.
Those are all
Yeah,
enterprise grade. Yes, I
yeah,
didn't want to go into that level, but yes,
yeah.
Salesforce,
But I think,
Workday,
yeah, and
and
this HubSpot, all the CRM
exactly.
software, like most of the CRM softwares, we can call them
Even
multi-tenant.
something that we use every day, Jira.
Yeah.
Those are
Even
all
GitHub, I
multi-tenancy.
think, is considered multi-tenant, right? GitHub can be considered, or can it?
So
Um,
here's the thing. It's very weird, but GitHub can be considered multi-tenancy, but it's more of a it's very collaborative. I
yeah.
mean, it's
Maybe the
it's
enterprise GitHub is multi-tenant, right?
Enterprise
Enterprise
GitHub
version.
is
Yeah, yeah,
multi-tenancy. That's correct, yes. So
yeah.
Enterprise GitHub, that's on the cloud, where you use GitHub Cloud, or the SaaS version of GitHub for your
Mm.
enterprise, that is multi-tenancy.
Also,
That's
like most
correct.
of the time, you get, subdomains. Like let's say
Correct.
you can put a subdomain, and it's basically your own
It's white
version
labeled.
of the white label product.
Yeah, that's correct.
Um, yeah,
So with multi-tenancy, what happens is you have your entire software. The only difference is that when you're saving this and stuff like that, you need to be very careful about it because there are lots of regulations specifically for us in the EU, the UK, as well as the US, and all these other countries as well. There are lots of regulations on how you actually store this data. So
yeah,
one thing about multi-tenancy here is that when you actually move into this phase of your product, your multi-tenancy, this SaaS phase, you need to be very concerned that basically your software cannot govern which record in the database it's accessing. what can govern that is only the database. So, for example, you are logging in to Facebook, and by mistake, Facebook sends my profile picture and my first name, last name onto your profile. That would be a multi-tenancy violation because nobody is supposed to see that on your profile. Or if we go into a much more critical sort of aspect of multi-tenancy, if you talk about salaries, instead of your salary on Workday, say you're using Workday or Salesforce, instead of seeing your salary, you're seeing someone else's salary
Yeah,
on your profile. And
yeah,
these are sort of very critical data breaches that's covered by GDPR and all these other regulations. So
yeah.
you need to be really careful about that.
Yeah. I think, Damon, for me, what I mainly think is, making it independent. So one client doesn't know about the other client, so that we can, I mean, simply saying that
That's
can
correct.
be, yeah,
That's quite correct. So yeah, so let's just. I mean, now that we've sort of set the sort of foundation of that, let's jump into this article. So yeah, they say here the multi-tenancy a core benefit of SaaS. So SaaS is actually built around multi-tenancy. So SaaS, if you don't know, is software as a service. It's basically you sell it as a cloud product, and SaaS is completely built on top of multi-tenancy. So um, so Digital Guardian's data protection platform, okay, so they have their own platform, leverages software as a service or SaaS to provide data protection in a package that results in superior security, better economics, and reduced overhead. One of the ways we do this is through the multi-tenant architecture. That's correct. So
yeah.
single
Just, just,
tenant.
uh,
Mhm.
just imagine if you have a enterprise product and you have to deploy server for each of the customer you have. Like if you have, I don't know, 10,000 customers this year, it's going to be a total mess for the
It's going to
company.
be a mess. It's going to be a
Yeah,
mess, and it's also going to cause. You will have a lot of points of failure.
yeah, exactly.
So,
So
for
just,
example, you, you might want to deploy a new. Okay, so say for example you have a SaaS product. You call it a SaaS product, but it's in fact not multi-tenancy. It's a single tenant. So what you're doing is you call it SaaS, but I mean you just put the facade. You just put the label of SaaS on it. But what you're actually doing is you're going and deploying these on different servers, different databases. You're going to deploying this either on your own cloud platform or on the client's cloud platforms. And whenever you want to push an update, you're completely screwed because you
yeah,
have to update. Uh, like if you have 100 clients, you would have to update 100 databases. You would have to update 100 servers or Docker images. You would have to update if it's in different AWS accounts, for example. For the client's own accounts, you would have to go into each of those accounts and update them.
yeah.
It's possible. It's possible with stuff like Chef, Puppet, and there's these tools, DevOps tools that
Automation. Yeah.
allow you to do that. But it'll be a very long and complicated process. I mean, to push one update, I'm pretty sure it'll take you a very long time. The key thing about SaaS, one of the reasons that a lot of people actually like SaaS, and a lot of reasons why even I prefer working for SaaS products, is that there's this thing that it's the lead time to releases. So it's the number of times you actually release per day. I don't know if it's called lead time or the actual number of releases you do per day, but basically, as a person is using the software, they don't know about it, but it has updated on the back. If there was a bug in 1 second, it would be gone in the next second. If there was no bug in 1 second, it would come in the next second. But it's this agileness of SaaS products that makes it so great. So you don't need to bother anyone. You don't need to tell anyone, okay, look, you need to log out and log back in. You need to re-download this patch for this fix. We just do everything on the service
Over
itself
there. Yeah,
over the air, and it just works. So it's this speed of deployment, speed of release that's one of the reasons that developers really love SaaS products, because it's very easy for us to. I mean, you can easily push 100 updates a day, and maybe companies are doing that. I mean, Facebook, maybe they do that because it's very rare that we actually see a critical bug on Facebook. It would be like even if they do detect it, they do detect a critical bug on production, they would be able to fix it like that.
yeah.
Um, okay,
So I
so
think, yeah, here they mainly talk about, advantages and disadvantages of single-tenant. I think we discussed that very clearly without even,
Correct.
going through much.
Correct.
So if
There's
we
one thing
jump
here.
into, yeah.
There's this cost that we didn't talk about.
Oh,
So,
yeah, true.
single tenant typically allows for more resources, but at a premium price, given that there is only one customer for the entire environment. So this is quite
No,
true.
yeah,
So, for example, you would have a database. You would have a RDS instance on AWS per customer, which is
yeah,
really expensive. It's much more cheaper to actually bump up the grade of your RDS instance than to actually have a completely new RDS instance of like 100 GB across multiple availability zones on AWS. Um, and then again, multi-tenancy, affordable cost. So multiple customers means that the cost of the environment is shared. You don't have to tell your customers, look, you need to pay this amount of money for the cloud platform for AWS. You need to pay this amount of a royalty or this amount of a license fee for our product. Or you don't have to package all of that together and charge a really exorbitant price, because then your price will be defined by the cost of the cloud service provider.
yeah.
Because
And
if
just,
it,
yeah, if you imagine, if you had to deploy, like, get a paid version of Google, that's a Dropbox, for
yeah,
example. So if each customer is having an independent one, they'll have to, like, they can't just survive with $10.
they
They'll have to pay,
cannot.
like, I don't know, $100 a month. So
Yeah,
yeah,
that's
I
correct.
think that's a huge advantage. I mean, that's the main advantage which you are
That's
trying
true.
to, yeah, come from.
Yeah. And then
Um,
then there's this integrations also. So cloud environments allow for easy integration with other applications through the use of APIs. I mean, you would see this. I mean, on Facebook, you can sign in on Facebook. You can have other apps linked to your Facebook profile and fetch your first name, last name, your image, and stuff like that, profile picture and stuff like that. All these are because of the multi-tenant sort of nature of that. Hands-free maintenance. So the server technically belongs to the SaaS vendor, yes, which is us in this sense, meaning that a certain level of database maintenance is handled by the vendor instead of you maintaining the environment yourself. That's correct. So, for example, I mean, this is a benefit for the actual client, and it's also a benefit for us, because instead of having to go and update 100 databases, you only have to update one database in this sense.
yeah,
Yeah, potential drawbacks, limited management, customization. It's all in the hands of the SaaS vendor. Security, other tenants won't see your data. However, multiple users are allowed on the same database. So this is where it's actually very critical in terms of GDPR and other regulations, because security it should be at the highest level. Updates,
and
changes. Yeah,
yeah, basically like data protection officer, those sort of roles come into like
you
this
have.
level of
Yeah,
yeah. Otherwise, you
exactly.
can't, survive this kind of
Exactly.
like issues. Yeah,
I,
I
I, I
think they
think I
need.
think
Yeah,
every company has a data protection officer if you are bound by GDPR.
yeah, they
You
they
have to
have to,
have.
and like for a multi-tenant application, I think it's very crucial. And who has access to the admin DB or something like that? Like
Exactly.
he would have access to all the clients, no matter what.
No.
So that's a huge.
Uh, and with, yeah, if GDPR is another topic. If you go into GDPR, there are
Yeah,
lots of things. I
we'll have
mean,
to. It's
that's a
another
completely
podcast.
different thing. Yeah. For example, I mean, you remember like back in the day, we could, if you are working in Sri Lanka, India, or any of the other Asian countries, or any country that doesn't have like data protection guidelines like GDPR, you can just log into the production server. You can look at the client's sort of data there. You can't do that
Yeah,
with GDPR. There's a lot of sort of steps that you have to follow for stuff like that. And benefits of SaaS, multi-tenancy, low cost. We talked about all this.
I think this
Additional
this one
benefits, yeah.
basically we covered most of
This
the
is
content.
more or less done.
So let's get into the technical part. So I think we gave a lot of story.
Yeah,
So let's
that's
maybe
true.
go into Cloudflare one then. Or
Yeah, we can move into Cloudflare. So this is what is multi-tenancy, multi-tenant architecture.
so this is a
So
very interesting. I mean, yeah. I mean, Cloudflare blogs are really well well done. I mean,
yeah,
usually if they put an article out, it's superb in quality, and they are usually coming on top of the Google search as well. So yeah, I think this will be a very eye opener in terms of architecture side, cloud architecture.
yeah, that's true. So yeah, what they're saying is multi-tenancy means that multiple customers of cloud vendor are using the same computing resources. That's correct. Multi-tenancy is a crucial component of cloud computing. Yeah, cloud services are far less practical. Multi-tenant architecture is a feature in many types of public source cloud computing, including IaaS, which is infrastructure as a service, PaaS, which is product as a
Platform,
service, platform
platform
as a
as a
service.
service.
Sorry,
Yeah,
yeah, SaaS, which is
that's
software as a service,
software.
containers and serverless computing. I mean, containers and serverless computing can basically go inside these as well, I
Those,
think.
yeah, yeah. And I mean, I think like if we are at the point here, IaaS, AWS, what we are using is actually sort of multi-tenancy. So they might have one big dedicated server running most of our, I don't know, DynamoDB or things like that. So they are giving us the over sort of like high level part only. So yeah. So
I
even
think the way AWS does it is that what's multi-tenant about them is actually a very small part of it. I mean, it's very sort of nice if you think about it. The architecture, it's really elegant because um, if you actually think about it, you can't really separate the servers. Like say, I have an EC2 server, you have an EC2 server. We can't separate them physically. I mean, they could still be on the same the hardware. They can be on the same physical server, the hypervisor.
yeah.
But what's nice is that one EC2 server cannot directly connect with its neighbor per
Mhm.
se, because
It's all independent.
it's kind of really independent in that sense, and the only way you can do that is if you have a key or if you have prior permission, and that's all governed by KMS. So
Mhm.
basically AWS's entire security system there. So
Yeah.
it's
And I
like
think that advantage is, network power and things like that are shared with those EC2s maybe. Each of the EC2 in the hypervisor will have the same power connection, for example. I mean, that's a very basic example, but yeah, that's
that's
even
correct.
multi-tenancy.
And that's lower cost for AWS because they don't
Yeah.
have to have separate hypervisors or separate
Yeah.
physical servers per customer. So it's all in one. It's in multiple data centers, but if you think of it as one data center, it's all shared within all of
Yes.
that.
Yeah, true.
So the only thing that you can break it down further is you can take an EC2 server and you can run multiple containers within it. That way you can break it down into much more sort of lower context stuff. But even then, if you have proper sort of security, you should not be able to, like one container should not be able to sort of hijack or communicate with another container directly,
Yeah.
without leaving without communicating with maybe a load balancer or something like that. So
Yeah.
it's really nice. It's really elegant if you think about AWS architecture in that way. So
And this
here you
diagram,
have,
I think,
yeah,
summarizes.
that's true.
Uh,
So like one tenant, here you have multiple tenants. Um, yeah, this is sort of that as well. What is cloud computing? We know this. What are the benefits? Better use of resources, lower costs. So in this sense, lower costs would translate into much lower costs for the company, higher profits for the company, and you can also share some of these benefits with your customer. I mean, you can reduce the amount that you want to bill, or that you want to basically the price of your licenses for a
yeah.
customer, because previously you would be billing each customer for, like, each customer would have to pay for the hardware as well, basically. But here, a
Mm.
single hardware being shared among multiple customers means they also get the price benefit of actually being multi-tenant here. Then you have drawbacks, security risks, as we said, the noisy neighbor effect. If one tenant is using an inordinate amount of computing power, this would slow down performance. For other
I
tenants,
think
again, this should not be, yeah,
the fair usage policies in most, free hosting or small shared hosting, they have a free usage policy, fair usage policy, sorry. So fair usage is, I think, this is the main
this is
downside of that. Yeah, basically, if I try to, you know, run some application with high CPU power or high network bandwidth, that would affect all the, tenants in the neighbor. So that's basically, I think, a major downside. But there are huge, tools to limit those sort of activities, I guess, in that.
exactly.
Yeah.
Exactly. So I think the noise neighbor effect, you can actually see it quite well if you take like sort of smaller cloud hosting sort of companies, where they won't actually enforce the the CPU units or the memory units that your server can actually use, your virtual server can actually use. So again, if you jump back, EC2 in Amazon is actually a VPS. It's a virtual private server, and you would not see the same branding called EC2 on other hosts, but it's the same thing. It's virtual service. The way that Amazon handles it is that they set a hard limit on the amount of CPU units and the memory units that you can actually use, and based on that, they will allocate different hypervisors for you. Again, these are if you go into Amazon's sort of product page for EC2 servers, you would see different tiers. You would start with maybe the free tier, and then you would jump up. You would have 4 CPU units and X amount of memory units, and then you can jump up. So these are all hard limits on resources that Amazon has. So
Yeah,
again, the noise
even
enabler effect, you won't see it a lot in cloud, sort of if you use a proper cloud platform, but it is still sort of there.
I mean, even if let's say the invoice example we took, so there can be a company who's generating invoices, maybe 10 invoices per second, or a huge number, and it might affect other people, like other 100 customers in that cluster. So yeah, again, it can be applied on hardware and software both, I guess. So yeah, again, that's
But
a
yeah,
policy level thing most companies do.
that's great. But there's also this noise neighbor effect. If you think of it the other way around, I'm not sure what the technical term for this is, but for example, if somebody DDoSes one AWS EC2 server,
Yeah,
all the other servers within
we'll get
that within that availability zone will get affected
yeah.
as well. So if something happens, if something screws up with one, it'll probably have a butterfly effect on noise enabler effect on the rest of it as well, because they all use shared sort of
Infrastructure on
hardware
the
and
yeah.
infrastructure. That's correct. And also, if for some reason one hypervisor fails, you might have 2-3 clients losing some of their availability zones for certain
Yeah.
applications. How does Cloudflare help companies with cloud deployment? This is marketing for Cloudflare. How does multi-tenancy in public cloud computing? So public cloud is stuff like AWS, GCP, Azure, and all that stuff. And then we have most cloud
Container
providers
also.
define as a shared software instance. They store metadata about each tenant and use this data to alter the software instance's runtime to fit each tenant's needs. Tenants are isolated from each other via permissions. So again, this is how AWS runs it as well, using KMS. Even though they all share the same software instance, they each use and experience the software differently. That's quite true. In a container architecture, so this is sort of the second level of virtualization here. So you would have your hypervisor, which would be divided into virtual private servers. In AWS, it's called EC2 servers, and within each EC2 server, you would have multiple containers. So here you would have, this is like talking about the container part of it. So containers are self-contained bundles of software that include an application, system libraries, system settings, and everything else the application needs in order to run. Containers help ensure that an application runs the same. Yeah. Containers are partitioned from each other into different user space environments, and each container runs as if there was only the only system on that host machine. Because containers are self-managed, multiple containers created by different cloud customers can run on a single host machine. So this is correct. So basically, if again, this is a separate topic, but the way that the containers are isolated is they actually use a separate sort of there's an open source framework for containers. It's the only framework right now I think there is, and Docker is built on top of that, and that framework defines what exactly that container can actually see within the host machine. So it's not really virtualization, but it's very sort of it runs very close to virtualization. There's an article that I wrote on this as well sometime back. We can talk about that in another topic maybe. And then the next is in serverless computing. So this is also really fun. Serverless computing is a model in which applications are broken up into smaller pieces called functions,
So yeah,
and
I
each
think even
function
we also
runs on the
did
code.
multiple sessions on serverless and Lambda
Correct.
architecture. So I think that's very neat implementation of this
Mm-hmm.
multi-tenancy.
That's true.
because
So,
underlying architecture is hidden fast.
if you think about it, serverless computing, what happens is that they actually run in containers. So this is serverless is sort of actually I would say it's a marketing name for splitting the level of separation down into containers. So a normal customer would purchase a virtual private. Sorry, a normal customer, you me, would purchase a virtual private server, which is what they have in public cloud computing, and then we would run containers on top of that. But with serverless, what they do is they already have their virtual private servers, and they define containers on top of them, and those containers run whatever serverless code that you want.
Yeah, and imagine the cost benefit it would bring up. Like you don't have to own the two levels of
You don't need to
infrastructure.
think
You
about
just
any of that. You don't need to think about should you update your containers. You don't need to think about the operating system on any of them. You don't need to think about anything. You just need to provide the code in a
run the.
Docker file to run all this.
So I think
Um,
here they have mentioned, Cloudflare. Cloudflare Workers is their serverless platform, I guess, just to run small code
mhm.
snippets of Node.js. So I think that's the tool which Cloudflare provides here. But
Yeah.
that's just a minor, it's just one part of the puzzle, maybe because it doesn't have databases, things like that. It's just
This is actually really nice marketing. The Cloudflare
yeah,
serverless platform, Cloudflare Workers, uses Chrome V8. Node.js is built on top of Chrome V8. So if you install Node.js, you already have Chrome V8.
yeah. So it's
So
basically having built on that.
yeah.
Uh, yeah.
So
So the
this keeps
last one.
service functions totally separate, yeah. And private cloud computing. So these are like the smaller vendors. Um, so private cloud computing uses multi-tenant architecture in much the same way the public cloud computing does. The difference is that the other tenants are not from external organizations. So company A shares infrastructure with company B. In private cloud computing, different teams within company share infrastructure with each other. So what they mean here is private cloud computing is it's not just stuff like smaller cloud hosting providers, but also cloud platforms that you have within your company. So for example, Facebook is a good example of private cloud computing. They have their own data farms, data warehouses. They have their own they have their own sort of cloud computing network and infrastructure within themselves. Same with
And
Google, same with AWS. Yeah,
yeah, it's just for them.
it's
Facebook
only for
has.
them.
Yeah, yeah.
Correct. So even AWS started out with as a private cloud computing company. They were the cloud computing division of Amazon, the actual the product, and then they were like, okay, I guess we can make money from this, and they moved into public cloud computing. Same with Google, same with Microsoft, Oracle, all of these guys. So Facebook is actually one of the largest private cloud computing guys out there because they have their own server farms and stuff like that. And that's the end
Yeah,
of this guy here.
yeah. So I think the last one we'll have a look is an actual implementation maybe on AWS
Hmm.
blog. So that basically
Yes.
has,
So
yeah, there will be a
this
lot of AWS product, but just I get the idea. I think get the core cloud concept, we'd say. Um,
that's correct. So this is actually it's actually not written by AWS. Actually, it's from their partner network. So these are AWS partners who have written this article. But yeah, so basically, what they let's see what they have. This is an introduction, multiple deployment models, um, two deployment models, silo and pool, onboarding isolation, noise neighbor, performance, steering, profile of serverless SaaS. Okay, so this is they're talking about a serverless SaaS environment here. So again, when you talk about serverless here, as I said before, these run. If you go back here, I said that the serverless computing is actually sort of run on top of container architecture. If you remember, if you take the public cloud computing, the actual virtual private server, you won't really have a huge amount of noise enable problems because they are hard limited. But with container architecture, what happens is that it's very difficult to hard limit the resources that are to be used by that container. you can specify, you can say, okay, look, this guy will at most use 2 GB of RAM, or this guy will at most use this amount of CPU units. But it's very hard to sort of set a physical, it's hard to set a hard limit. So if you have 3 containers running on one virtual private server, and one container acts as a noisy neighbor, it's using too much CPU power, and the other 2 containers don't really have, they really won't be able to use a lot of CPU in this case. So for example, Node.js applications, very CPU intensive. If one application starts sort of processing a huge amount of work in a serverless architecture, the other 2 containers, assuming there are 2 more containers within that EC2 server, those 2 containers would be struggling for resources there. So that's one of the reasons that they're trying to address noise neighbor here within a serverless architecture. And you have performance and the tiering profile of a serverless SaaS environment. So for the silo model, you'll see each tenant has its own set of infrastructure resources. On the other hand, in the pool model, all tenants share a common storage as well as compute infrastructure. So you can read about these isolation models in the SaaS tenant isolation strategies white paper. There's a link to that. This serverless SaaS solution uses tiers to determine which model a tenant uses. Basic, standard, and premium tier tenants will share a common set of resources. Platinum tier tenants will have their own dedicated resources.
So I think this is basically a cross between, cross between the normal multi-tenant and, giving sort of one more step towards that, your isolation. So if you have very private customers, let's say a hospital comes on board, they might actually ask for a, independent environment. But again, it should be low cost so that we can, bundle up few high-end premium customers maybe. So that's the idea, I think, here. They have to, bundle sort of premium platinum customers together. So that's what I got from that, basic, standard, platinum, premium, sort of, yeah.
So what I understand here is that these 3 guys will be using this pool model. These guys will be using platinum, guys will be using the silo model here.
Yeah. I think in terms of, cloud development, if we build the product right, it can be converted into any of those needed. We build one product properly and it's multi-tenant, and it's a matter of, deploying to another server to make that dedicated resource, the premium, the platinum tier thing.
That's true.
Just have a look maybe. So yeah, this is a typical multi-tenant architecture based on AWS serverless services. So here, I think the idea is everything is shared, so there's no independence here. So every client could have the same architecture reference, like microservices would be the same. Everything is shared between them. So we have what we call a dashboard, and it uses Cognito, all the the typical serverless architecture stuff. The API gateway, authorizer. We have multiple services, and you can see there are like 3 DynamoDBs, right? Or 2, I guess. 3. So order product would, I think, connect to independent DynamoDB. So maybe they just represent them in 3 different ways. Not sure how that is.
I think what they're sort of saying here is that this DynamoDB instance is shared among all of these guys. And this is like actually multi-tenant here. These guys are also multi-tenant, but maybe because of the schemas that they require or the different sort of stuff that they need, they actually have 2 different instances here.
Again to make it more scalable, I guess one DynamoDB won't get all the hit at any given time. So basically, that tenant management has its own independent database. That makes sense. And when we have a 2-minute look here, we get the idea why AWS has recommended this
it makes sense because these shared services are more like managing users and stuff like that.
Yeah, basically managing the tenant.
Signups, the tenants, the users, and the provisioning part of it.
The other part is just the product.
They have the same DynamoDBs, yeah.
Exactly. So other part is just the core product. So let's assume it's a e-commerce site, orders and products. I think this is a very high-level view of how its high level view of like advanced serverless architecture, like multi-tenancy. So if you just scroll down a little bit, we can. So this is the baseline deployment. You can see the figure 1 is baseline. Then they have mentioned notion of serverless microservices. So that's, I think, one of the main things we are also like very passionate about in this channel. We are we have talked this multiple times about this architecture. So serverless design patterns. Uh, it's basically the implementation, connecting sort of the dots which you need to get right. After that, it's very production ready, we can say. So yeah, if you just scroll down a little bit, so this can be, the first step of the entire product. Without the multi-tenancy, this is the core, the base, without like the skeleton. So this is like one product, one uh, application. And for example, in our initial example, we got the invoicing software. So the product the company built for that company itself can be this architecture. Very simple, very straightforward, just get the job done. Then how we are going to make it expand. So I think if we go down further, we can explore how they are trying to, expand that into multi-tenancy. So each component they are breaking down. So there will be a registration layer. So that's the tenant registration layer. So that's the new addition to the old stuff. So this is entirely managing the tenant's registration flow. So we earlier had the application, now we had the tenant layer. Then we do the multi-tenant. So it's basically, putting it together. So it's not built one time, I assume. So I don't think we just build
So
this entire
here,
thing at once.
yeah, so here, one of the key things that actually governs this multi-tenancy here is this resource policy. So
Mm.
it's using this resource policy that DynamoDB, your software as well as DynamoDB, will be able to identify which exact partition within DynamoDB they need to access, which record they need to actually edit. Because I mean, if you as a tenant here, you would get your own resource policy here.
Yes,
If another tenant comes in, he would get his own resource policy. So because of this, it's very difficult to sort of say, even if
break.
somebody came into, someone hacked, uh, I don't know if it's possible, but someone hacked this serverless sort of container here. They got it to run and they injected some code into it. They would still not be able to access the DynamoDB sort of database here unless they were like really clever, because you would need this resource policy, you would need the KMS keys, you need a whole bunch of stuff in order to actually generate these stuff and send them to DynamoDB here.
Yeah, so I think here it's basically the entire tenant management part, the figure 3. So if we go to the next step, I mean, we are not going through like line by line in this doc. It will be very time consuming and boring a bit. So I think fourth diagram, Damien, it's the uh, code pipeline. So how it's going to deploy this multi-tenant architecture into, from build, like a release, how to do a release sort of thing. So here, what they have done is added code pipeline. That's Then they have multiple deployment tenancies. So stack tenant 1, stack pool, stack tenant 2. So this is where I think they have done, even in this architecture, they have multiple multi-tenant tenancies. Can you call that multiple multi-tenancies?
It's
So
yeah, they have different. I mean, this is normal in a normal software. I mean, you won't have like one huge database normally. You would have multiple databases as well. Like even if you take like, not instead of DynamoDB, if you take like, say you have Postgres on your servers, you have a bunch of microservices. You have the ordered microservice. You'd have the invoicing microservice, the user microservice. It's very rare that you would have one monolithic sort of database for all of this.
yeah,
You would normally just have multiple databases, because then each team, it's easier for the developers as well. Each team is in charge of their own database and they can do changes to that whenever they want. And if one breaks, everything doesn't break. So this is really normal. So here what they're doing is they have tenant 1, which might be that order sort of tenant. They have the pool tenant for all the sort of the common tenants that use the common database, and they
So
have
this is
tenant
where I
two.
think they mean their basic premium that package the deal comes in. So
Correct.
tenant one is fully independent. Tenant two pooled is maybe
Mm-hmm.
basic tier people, so they can have multiple environments in the same
Correct. Yeah.
manner, same
So
code base basically.
yeah, if you scroll
Um,
back up a bit, basically what they mean is that here, so they have,
Let me go to the last diagram. It shows clearly, I think, a figure five. Yeah, this one is
yeah,
clearly explaining, tenant one, tenant two,
yeah,
then shared
yeah.
tenants, the
So
basic tenants.
yeah, so basically these guys would be one tenant. These guys would be another tenant. These guys would be another tenant, and you would have more tenants. So basically,
So
they consider these lower levels, lower tiers as one complete tenant, and then different tenants would have different services here.
yeah, but the key, what you call key input to key insight to get here is basically you can see the shared services, which is tenant management is just one.
Mm-hmm.
Entire thing is managed by one big tenant management component, and all the other things are completely sort of independent from those. So the platinum tier is fully siloed. No one can have it's not pooled with shared with any of the other any of the customers. Basically their own DB, their own functions running up. But for
Mm-hmm.
example, the other one might have 100 different clients in that same DB, but it's again protected because of the policies and keys and access
Mm-hmm.
level token. So yeah, this is very interesting. I mean, this is very advanced, I guess, a little bit. But this is where
I
a company would start from the very basic level. You have a multi-tenant, then what's next? So this is the next thing
I think this is sort of like the architecture for GitHub, because
I
you'll
see, like
see
private tenants.
GitHub, you'd see GitHub the normal open source here,
Yeah,
and you would see the enterprise services like these separate tenants here, and all of their
exactly. Yeah.
management goes in like one part.
One login, one GitHub login. Yeah, true. So this is actually we can consider this like real world architecture because this is again written by a partner, right? So maybe they have a case study similar to this,
Mm-hmm.
and they wrote that case study here.
Mm-hmm.
Uh, so the what's the last one? They have again another layer of API based authorization,
Mm-hmm.
tenant isolation. So those are all when you have this level of separation, you can keep on building more and more limitations, resource locking. So it's all about growing from the growth level. So these are all like when you come to that level, it's basically to scale
Mm-hmm.
further and further.
That's true.
Um,
Yeah.
I think we covered a
So.
lot of content in this article. I mean, in terms of technology, right?
Mm-hmm.
It's very interesting. We first started with the story, sort of why it's happening, why we need multi-tenancy, then why a company would need multi-tenancy, and how would it benefit the advantages, and why not to go with single tenant, and then a real world sort of implementation on AWS cloud, basically serverless
Mm-hmm.
architecture again.
So this, I mean, there's one little drawback here. I mean, this is an example for this is an IAM policy um, for uh, for DynamoDB here. So basically, what this says is, look, we need you guys to create a policy for this table, and the condition is that they can sort of update, get, put, delete, query. They can do all of these actions in DynamoDB. If you have a partition key, a leading key that matches this sort of this index here. The problem here is one of the sort of drawbacks, maybe you can say. I'm not really sure, but is that you would actually need to, like, each time here, for example, in this authorization flow here, this authorizer always needs to communicate with IAM and STS, and get back the sort of proper policy
Yes.
for each and every request that comes in. So you have this little sort of extra hop within your sort of request lifecycle. You always have to you always have to build that sort of this policy here. You would always have to build this policy, and you would always need to not exactly this policy, but you would need to build a policy, and you would always need to query IAM and STS to return the rights to do all of that. But basically the meaning of this is you would be able to you would not be able to sort of affect any of the other tenant sort of records belonging to other people within the same table. It's much more easier to sort of do this on something like Postgres, because Postgres has this thing called row level security. So let me just get that for you guys. Row level security, PostgreSQL. So it's really simple. Row level security is basically you have this extra condition on your server that says, okay, for these users, for these database users, always do a where check, an additional where check, based on whatever context they have.
So
for
the code will
example,
be very clean, right? Code
the
won't
code is
have
very clean.
yeah.
You won't have to communicate with someone else and say, okay, give me the key for
Maybe
this, give
company
me the
ID or
policy
something
for
like
this.
that.
Yeah, nothing like that. If you have the proper sort of tenant ID or whatever within your request scope, if you are able to actually inject that properly into sort of your query properly, you will not be able to access any other record on your database. Even if you have, like, say, multiple tenants in the same table, you would still not be able to access any of those records, because it's not allowed for any use. Once you set up a row level policy on Postgres, you would have to create another user with disabled row level policies before you can actually execute stuff on top of that. So you can't do stuff like select all. You can't do select all. You can't do delete all.
Even select all would enforce company ID
Yeah,
equals something.
it would enforce in the background. It would enforce if you have like a proper sort of middleware written for this. You could encapsulate it and you could abstract it, and you can say, okay, a developer type select all. In the background, it goes, okay, select all where tenant ID equals this guy. So it always adds that where clause at the end.
And that tenant ID can be from the authorizer and passed down to the row level security.
That's true. If you just go into MySQL command line and you try to just execute select all, it won't work. You will get an error saying row level security has been bypassed.
Yeah.
So
that's really cool, I think. Yeah.
So this is like a much simpler way to do this, but here it's basically this extra hop you have to actually do here, but it's fine for serverless applications because.
And I think they mean this is because like document DBs, right? You can't. I mean, it might be tough on document DBs to do that sort of validation. I'm not fully sure, but yeah, you can do a middleware doing enforcing that where equal part.
So
tenant ID.
The thing here is I don't think all document DBs are supported for multi-tenancy like this. I think MongoDB has a separate sort of implementation. Because this is a AWS managed product, they require you to actually go and use IAM for this. There might have been a different way for them to implement this, but because they want people to use IAM as well and STS, you actually have to go and it's actually more secure in this way as well. So nobody can actually go and inject weird stuff and actually do stuff like that.
All right. I think we covered a lot of content and shared some experience as well on this area. And Damien, just to, we talked all about serverless here, but when it comes to a real world application, maybe like the industry you are working on, so you have real world, let's say a Java application. How complex would that application, we talked about AWS a lot, but when it comes to an industry project, it might be their own containers. It's not Lambda, it's their own container. So how complex would that be to make it multi-tenant? I'm just curious to know.
So in order to make something multi-tenant, it's like this. If you're moving from a single tenant application and you want to make it multi-tenant, the initial development for that would take some time, but afterwards it would be very easy.
Because of the low level implementation like database queries, things like that.
Right? Exactly. You need to set up these stuff. You need to set up isolation. You need to make sure that all your primary keys are proper. You need to make sure if you're using SQL sort of stuff, you need to make sure that you have tenant IDs on each and every table. So you have a column called tenant ID on each and every table. You need to make sure
Mhm.
of stuff like that. You need to test it very, very, very thoroughly, because when it comes to stuff like GDPR, if you have
Yeah.
one leak, that's 10% of your revenue
Yeah.
out the door.
True.
So it's the initial setup of it is, it's not tricky. It's possible, but it takes a bit of time. But
I see.
afterwards, once you start actually continuously developing it in an agile way, it's really easy,
Oh, yeah. Yeah.
because you don't have to
Uh,
manage tons of databases. You don't have to manage tons of servers. It's all
exactly.
like one
Because
thing.
a company might decide, okay, no, we can just redeploy the same project in another container, and they might get stuck. Okay, we have done 10 of that. Now, if we are changing one line of code, we have to deploy on all the 10.
Hmm.
So, you have to identify, okay, we are going in now. It's like investment for the company. Let's start everything from like rewrite
Hmm.
everything to support multi-tenancy. So
Yeah,
I think it's a good,
there it would be a problem, because they would have to. There it would be a little bit more difficult, not too much, but they would have to migrate all the data into one sort of
yeah.
database, or into whatever way they model they decide. But they would still need to do a data migration there, so there'll be
Yeah,
a
I think
little bit
even if
of
it's
downtime.
yeah, even if there's like a slight vision of the company to go multi-tenant, like multi-clients, maybe it's better to, I think, deploy like develop from that level. So if I'm doing, let's say, some small project, uh, again invoicing. So if I'm so sure if it won't go live to other people, then it's okay. But if I have like a small think like thought, I might sell this to other projects, other clients. So then we have to start from there. Otherwise, it's too late. I think that's the learning we have to get from this architecture
That's correct.
patterns.
That's correct.
Yeah,
I mean,
architectures are there, but again, development level, you have to sort of struggle a little bit if you are like not thinking like way forward.
so yeah,
uh,
yeah. I mean, I have one example that that happened to us as well. So this is some time back, but I said before that, like, for each table you'd have to make sure you have some sort of tenant ID or something like that, right? So if you
yeah,
didn't have this at the start when you were developing a single tenant application, and now your table has millions of records, millions of rows in
yeah,
records. Um, Add in a new non-null column to
yeah,
all of these would put your CPU to 100% one thing on the database, and the next it will take hours to do
yeah.
this change on the database, because
I know.
although
Yeah,
this is on AWS side, the database is on AWS side, it's a RDS instance or something like that. It's still limited in the amount of resources it has.
and
It's
I think it's
limited.
again going to crash to the for the
it
users. Like they won't.
It'll be yeah, you can't, I mean, while you're it would basically because that's basically a migration. You would lock all the rows on the
Mm,
database, so users can't actually go and update any of the rows. You'd lock
yeah,
them, and then you would actually go and add another column with the
SQL
separate
query
tenant
again.
ID. Yeah,
Yeah,
this would take a long time to
I
run
see.
this.
Yeah,
So
yeah, true.
these are like the pain points of migrating from single tenant to multi-tenant.
That's a very good input, I think. Yeah. So I'll keep that in mind when developing apps in the future. Yeah, I think we can wrap this session today. It's about all about multi-tenancy and the cloud side of it. So yeah, let's wrap this session for today and see you
Definitely.
guys
And
in the next one.
I know we were on a break, but we hope to continue
Keep continue. Yeah, of course.
on a regular
Yeah,
basis all these
yeah.
videos and these updates. So if you guys like this, drop a comment, drop a like, let us know, and see you guys next time.
See you.